This will be the third and final video for the PK MACH boiler with the ENVI controller. I want to go over a couple, look at these operation manuals. Here's one from 2009, here's one from 2015. A little bit of different information in the two, and really, you know, if you're working on a boiler that is newer than 2015, obviously you'll want to use this manual. Older, you'll want to use this manual here. Let's look at this one first. I want to go over just a few things real quick. On this one, it tells you on the supply temperature sensor, if it is open or shorted, this is the actual temperature indication. So the supply temperature sensor will never read a temperature below 14 degrees. If it shows 14 degrees, you know the sensor is open. If it shows a temperature of over 244 or right at 244 degrees, you know the sensor is shorted. That holds true for supply, return, and domestic. And you see here flue gas temperature is a little different range from open to shorted. But a sensor failure, you need to recognize that, you know, it will read that. If you disconnect the sensor, obviously you're going to get the lower reading. The other thing here is the flame signal. It's in microamps, and anything below 1.7 is flame not detected. And I'd like to be able to show you that. I have trainers in my classroom. You know, if we ever get back to in-person classes, I need to show you how to measure a microamp signal on a flame rod. Is very important information. You know, if you've never pulled and cleaned a flame rod, you know, that's typically all you really need to do. It's a piece of metal. I can show you how to use a crescent wrench as a flame rod, but that isn't practical, but you can do it. It is just measuring current through the flame, and it's read in microamps, and you think microamps, that is 1/1,000,000th of an amp. So 1.7 microamps is 0.00000017 amps. 17 millionths of an amp. That's or 1.7 millionths of an amp. That's not very much current. You will not clamp your little clamp meter around that and get a reading. It doesn't read to that low of a range. So it's important to know how to do that. But the nice thing about this boiler is that you actually can see the flame signal right on the display. You don't have to get a meter out to do that. Several different modes depending on whether you're doing set point with the thermostat. You know, you set the boiler to maintain 150 degrees and you turn it on and off with the 24 volt thermostat input. Or maybe you're using an outdoor sensor control. You know, there's a lot of different options here. If you have multiple boilers, you'll probably use a header sensor, which is a common header. If you're using an analog signal to change the set point, or an analog signal to adjust the firing rate, these are all different applications or different ways you can control this boiler for different applications. And it's important to know that these features are available, because, you know, you may be on a job where they set it up as a set point and stat, and really what you need is something like an outdoor control where the boiler water temperature changes to match the outside temperature. You know, not as hot when it's warm outside, and bring the temperature up on the boiler when it does drop outside. That's called outdoor reset. Here is a internal set point, stop, start, and you know, let's say I guess in here they're using the set point as 160. The off hysteresis. Hysteresis is another term for differential, just a fancier term, I think. So 9 degrees versus 10 degrees. So hysteresis to shut off is 9 degrees. Hysteresis to come on is 10 degrees. Set point's 160. So as the boiler temperature drops to 150, the boiler starts. Comes up to 160, starts modulating, goes from high fire down to low fire. Now the temperature is starting to rise above 160. It's at low fire. Maybe there's no load, so it finally drifts up to 170, which is 10 degrees above or 9 degrees above. At 169, it shuts off. Boiler temperature drops gradually, and comes back on right here. So that's over, say, about a 35-40 minute time period. That's not too bad. And you might wonder, if you wanted to maintain a tighter water temperature, maybe you set the set point at 160 and your on-off differentials or hysteresis at 5 degrees, so you only have a 10-degree range. The thing you got to think about is that most boilers, when they start, they will raise the water temperature from the inlet to the outlet about 20 degrees. So it may cause the boiler to short cycle if you set this differential from 20 degrees or 19 degrees from on to off down to like 10 degrees on off. You probably have it short cycling. And any time you got a boiler that's stopping and starting more than 6 times an hour, every 10 minutes, you really need to think about how much wear and tear you're putting on the boiler. Here's the excuse me, outdoor reset schedule. At 0 degrees outside, we're going to have 180 degree water. Excuse me, as the the outdoor temperature goes up. Now we're at 70 degrees outside temperature. We're going to have a boiler temperature at 80 degrees. That's called outdoor reset. So if you looked here at 30 degrees, you would have about 135 degree water set point. But here's the scale for that. 70 degree outside, 80 degree water temperature. 0 degree outside, 180 degree water temperature. 9 degree or 10 degree on differential, 9 degree off differential. So that's a common outdoor reset. And of course, if you got outdoor reset, or if you're using outdoor reset, you have to pick the right mode, like maybe mode 6, and you have to have an outdoor temperature sensor. It's not optional for that mode. You have to have it. Let me go back and look at the 2015. I just want to show you one thing here, because this will be on the quiz. Here's where it talks about the 12K thermistor, 12,000 ohm, and 12,000 ohm is its resistance at 77 degrees. That's why it's called a 12K thermistor. If you remember on the Bryan and Cleaver Brooks boilers, they typically used a 10K thermistor. It was 10,000 ohms at 77 degrees. Well, PK decides that 12,000 ohm is better for them for no reason other than it probably makes the sensors a little bit harder to buy from anybody other than them. That's their way of keeping their parts. But take a look at this curve here. Not all thermistors are linear. If it was linear, it would be a straight line from this point to that point, but it's not. It follows this curve, and the important thing to remember is that it is not negative temperature coefficient, NTC, which means that the resistance at the lowest temperature is real high, and as the temperature goes up, the resistance goes down. That is the definition of negative temperature coefficient. All the settings, there are OEM settings that you will not be able to change unless you get the password or go to PK school when they give you the password for that. But there's a lot of information on the status screens. I do want to get down to here on the status screens. You can read the temperatures, but you can also read the status of the low gas pressure switch is either on or off, and the indication is going to be a 0 or a 1. 0 means it's off, 1 means it's on. That's just the way digital things work. Error codes, if you do get an error code on the newer models like the 2015 and up, it'll tell you a little information about when the error occurred, date and time. This is good information for doing troubleshooting, to actually know what the error code was. We'll scroll way down here. One thing I want to go real quick. If you got multiple boilers, one of them has to be a master and the rest of them have to be a member, and typically the master is the one that you hook the header sensor to, just in case you ever have to do that. So here are some of the errors you might see. This is showing there is no flow. It gives you an error 01. The temperature sensor, return temperature sensor is open. Flue temperature, domestic water temperature, header sensor is open. Different error codes on this page here. Here is a flame error, flame detected just before the gas valve was open. That's probably a bad thing. Flame still present 10 seconds after the valve is closed. Another bad thing. You don't want the flame to maintain or stay on after the gas valve closes. That would be a real problem. Here, the flame check error, ionization, flame rod, wire lost for more than 15 seconds. All these different things, when you look at an error code, an alarm code, you really want to know exactly what that means. And here's the description for that, kind of things that you really should keep track of. If you have a hang tag, anytime that you cause an error, maybe you caused an error by shutting the flame off or pulling the flame rod wire off just to see, to test it. You'll want to put that on your notes on your hang tag that you had a certain error, so that next time around when the last fault was and why, who was there and what caused it. So I'll be asking some questions about what you've seen in the ENVI operation manuals on the quiz, just because I think it's important that you know how to use all the literature and all the available information to do troubleshooting on a boiler now that you got a little better idea of how the wiring and the controllers operate.